Okay, guys, continuing on, I'm doing another example of using the rational zeros theorem. So I'm not given any possible zeros to check or anything like that. And I'm going to try to get this fully factored into linear factors. Okay, so once again, rational zeros theorem. It tells me to take all the factors of my constant at the end, okay, whatever constant term I have. So in this case, it's going to be factors of -6. And on bottom, I'm going to take factors of the leading coefficient. So the coefficient with the variable to the highest power. So in this case, it's the 2. So factors of 2. So this is a little trickier because remember we said if we just have factors of 1 on the bottom, it just ends up simplifying to whatever we have up top. So this is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. On bottom, I get plus or minus 1, plus or minus 2. So what I do is I go through, I do all the top ones paired with the first one, and then I'll go through and do all of them paired with the second one. And a lot of times you'll get overlaps. You'll see what I mean here. So I got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 so far, okay? Now, if I take plus or minus 1 over plus or minus 2, well, that's just plus or minus 1/2, okay? I'm going to continue right here. Now, if I take plus or minus 2 over plus or minus 2, well, that's plus or minus 1. I already have that. Plus or minus 3 over plus or minus 2 is just plus or minus 3/2. And plus or minus 6 over plus or minus 2 is plus or minus 3, which I already have. So you do encounter a lot of overlaps. You don't have to write them down again. But what I got to do is I got to start checking these to see, well, which one's a 0. How do I check if it's a 0? Do your synthetic division. So I'm starting with 1, positive 1, and see if you get a remainder of 0, like we did in the last example. So I'm going to do my synthetic division. So bring this down, 2, 5, 5, -6, -6, -12. So based on this, 1 is not going to be a 0. Okay, that's fine. I'll move on to -1, 2, 3, -11, -6. Keeping my fingers crossed that I don't have to do too many of these. 2, -2, 1, -1, -12, 12, oh, 6. -1 didn't work either. That's okay. We did plus or minus 1. I guess let's move on to the 2's. So if I check 2, so 2, 3, -11, -6, 2, 4, 7, 14, 3, 6, 0. Hallelujah. So what did this tell me? From this, I know that 2 is a 0. And if 2 is a 0, what do I know as a linear factor? I know x minus 2 is a linear factor. So now let's put this all together, okay? Keeping in mind, remember, this is my leftovers, right? So I know that P of x is equal to, I know I can pull out an x minus 2 since it's a factor. And if I divide P of x, what I started with, by x minus 2, here's the leftovers. So that's going to be 2x squared plus 7x plus 3. I want to try to fully factor this. So let's see. P of x equals x minus 2, okay, 2x, x. Let's see if anything works. How about a plus 3 and a plus 1? 6x plus an x is 7x. And we got 3 here. So this is fully linear factors. If I wanted to add on about the zeros, I would say this. The zeros are going to be 2, -3. I got the 2 from this one, and I got the -3 from this one. And then these ones, sometimes you just need a little work, right? So how did I find this? I just said, well, how does this equal 0? And how did I find this one? I said, how does this equal 0? So I'm going to look at this one and say, well, what's x when this is equal to 0? 2x would be -1. X would be -1/2. So whatever they ask me, if they say, write this as linear factors, I'll write this. If they ask for zeros, I'll write this. If they ask for both, I'll write both. Okay? Next thing I want to talk about is the multiplicity of a 0. So the multiplicity of a 0, which corresponds to a given linear factor, we know zeros and linear factors, they correspond to each other. If we have one, we have the other, is the power, and I underline power, the associated linear factor is raised to. So for example, if I have f of x equals x squared times x minus 2 times x plus 3 to the 4th, so nice and factored into linear factors, okay? Well, it is linear factors. I know you got to be careful. You're saying, well, what about the 4 here? That's going to tell us about our multiplicity. The important thing is x plus 3 itself is linear. X minus 2 itself is linear. And if you think about it, x itself is linear. Okay? So I know from this that I have zeros of 2. I got that from here. Okay, so I'm not going in any, well, I am going in a particular order. I have a 0 of 0. That's from this part, right? And I have a 0 of -3. Now, technically, x minus 2 is to the first power. So right here, this 0 has a multiplicity of 1. This one right here, this 0 corresponding to this, has a multiplicity of 2. Why is that? Because this linear factor is raised to the second power. And this guy right here, the -3, has a multiplicity of 4. Reason being, right here, it's this 4. So it's whatever the linear factor itself is raised to. So a lot of times it's 1, but sometimes it's something more than that. And this multiplicity is going to be important in 3.4 because it tells us a few things about the graphs when we look at them. Okay. So let's keep moving. Example 3, find a polynomial function, f of x of degree 3 with real coefficients that satisfies the given condition. And it says we have a 0 of 2. So I'm going to just start writing this down. F of x equals, I know this has to have an x minus 2, right? Because if I take my 0 and I put it in, that'll make it equal to 0. And if I have this all factored, it makes the whole function equal to 0. It also has a 0 of 4, but the 0 of 4 has a multiplicity of 2. So I guess that would look something like this. Okay, so make sure through that first part you understand how I got all this. Now, you're saying, okay, why isn't that good enough? Well, we have this condition right here. F of 1 equals -18. Well, shoot. I think if I put 1 in there, I don't think I'm going to get -18. And in fact, I won't. So how the heck do I make sure I get -18? What we need is we're going to need a constant, okay? So the trick for this is I'm going to put k for a constant. I'm going to find k, and that'll force this condition to be true, okay? So a constant, it could be like a 2 out front, a 5, 1/8, you know, something like that, okay? So how am I going to do that? I'm going to use this guy right here, okay? In fact, actually, I'll do it in blue. So f of 1 equals -18 tells me that my function value is -18 when x is equal to 1. So I have k times 1 minus 2 times 1 minus 4 quantity squared. And notice now I can solve for k. And I know that that'll be the correct k because I know it'll satisfy when y, or the function value, is -18 and when the x value is 1. So -18 equals k times -1 times -3 squared. Okay, so we're right here. And as we go, let's see what we got here. We got -18 equals k. -3 squared, that's 9 times -1. I guess that's k times -9. Divide both sides by -9, and we get 2 is equal to k. So we almost had our answer here. We just need to know what k is. Now I know what k is. F of x equals this k value of 2 times x minus 2 times x minus 4 quantity squared. And we are good to go.